Hi friends, trying something new here using my document camera to explain to you how we convert improper fractions to mixed numbers. So let's quickly recap how we would draw any old fraction. I'm going to draw 3/4. 3/4 is a regular fraction. There's nothing special about it. It has a numerator that is smaller than the denominator. So if we drew a picture of 3/4, we'll make a famous candy bar. The denominator tells me we have 4 parts total in the whole candy bar. And the numerator tells me that we are eating or we have 3 parts for ourselves. 1, 2, 3. So that is what a drawing of 3/4 would look like. But the difference with improper fractions is that our numerator is bigger than the denominator. So this is called an improper fraction. How improper of it to have a larger numerator than the denominator. Now, we start out the same when we draw the picture. 4 tells us how many parts are in the whole. Okay, there's 4 parts in the whole, but we have 6 parts. 1, 2, 3, 4. Uh-oh, I ran out of parts. I'm going to have to draw another whole candy bar. Divide it into 4 pieces because that's our denominator. So I've already taken 1, 2, 3, 4, now 5, and 6 parts. That's how we would draw the improper fraction 6/4. Now, if I said to you, I want you to take this improper fraction and make it a mixed number, we'd have to look closely at this picture. Well, if I look at this part of the picture here, I can tell that I have 1 whole candy bar colored in. But when I look at this picture or the part next to it, I can see that I have 4 parts total, but only 2 of them are colored in. So if I convert 6/4, the improper fraction, into a mixed number, I'll take these 2 things I wrote here and I get 1 2/4 for my mixed number. So 6/4 is equal to 1 2/4. Let's try another one. I'm going to get a brand new piece of paper here. If I had an improper fraction that was, let's start with a different denominator this time. Let's say our denominator is thirds, 3. I'm going to say I have 7/3. Okay, you can tell it's improper because the numerator is larger than the denominator. If I were to make candy bars, I would make my candy bar divided into 3 equal pieces. Let's pretend those are equal. Now, because it's an improper fraction, I know I'm going to have to draw at least 2 wholes because improper fractions are always more than 1 whole. That's why they're improper. The numerator is larger. It's always going to be more than 1 whole. We may end up needing more than 2 wholes. We'll find out as we do the work. So 3 is our denominator. You can see I've made my whole candy bars in 3 pieces, but we have 7 pieces. 1, 2, 3, 4, 5, 6. I have to make another whole candy bar to get 1 more piece, and 7. So that is what an illustration or a drawing of 7/3 looks like. Now, any one of these candy bars that's completely colored in, I know is 1 whole. So this is 1 whole candy bar. This is 1 whole candy bar. This last candy bar is not completely colored in. So I'm going to make my denominator 3 because I know there's 3 parts in the whole, and 1 of them is colored in. So now that I look at what I've written, I have 2 wholes and 1/3. So this improper fraction can be converted to this mixed number, and they are equal to each other. They mean the same thing. 7/3 is equal to 2 1/3. I'm going to do one more right now, and this one's interesting. I'm going to say my denominator is 5, and I'm going to say my numerator is 10. I hope that looks like a 5 to you. Okay, so 10/5 is what we have. All right, I know it's improper. Why? Because the numerator is bigger than the denominator. I know how many parts are in each whole candy bar. 5, because 5 is my denominator. So there's 5 pieces, and I know I have to draw at least 2 of these, maybe more, because all improper fractions are more than one whole. Now, I keep saying candy bars, but you know sometimes when we're talking fractions, it can be about other things. Candy bars just make it easy for me to stay focused because I love chocolate. All right, so I have my 5 pieces in each whole, and I get to keep 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, look at that. It fits in perfectly. I don't have to draw another whole candy bar. So I have 1 hole and I have 2 holes. Interesting. So I should probably just label that 1, and then when I put the 1 and the 1 together, I get 2 holes. Now, this is converting from an improper fraction to a mixed number, but this mixed number just ends up being a whole number. So 10/5 is equal to 2 holes. Interesting. I don't know if you noticed anything about this, but I notice that the numerator is double the denominator. I wonder if that's something we'll notice when we do some other conversions. I'm going to do one more as an example, and then I'm going to have you do some on your own. Okay, the last improper fraction that I'm going to write, I'm going to make my denominator 4, and I'm going to make my numerator 9. Okay, so I divide the whole into 4 parts, and I know I have to do at least 2. So we'll start with just 2. And we're going to count out 9 pieces. 1, 2, 3, 4, 5, 6, 7, 8. Looks like I need to draw one more. And divide it into how many pieces? 4, because that's the denominator. So 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, let's see how we did. 1 hole, 1 hole, and this one has 4 parts and only 1 is shaded in. So what mixed number would this be? Yeah, this would be 2 1/4. So this improper fraction, 9/4, is equal to this mixed number, 2 1/4. I hope this video is helpful, and always feel free to return back to it when you're doing the practice problems on the next slide.